All right, today we will be talking about using special right triangles. We will be able to find the side lengths of special right triangles. Right triangles are those whose acute angles measure 45 degrees and 45 degrees or 30 degrees and 60 degrees. So our first type of special right triangle we're going to talk about is the isosceles right triangle, where it has two angles of 45 degrees and the other is 90. Remember that if two of the angles are the same, that the sides opposite them are also congruent. So this leg is congruent to this leg. If we want to find the hypotenuse, the rule for the hypotenuse is that it's always equal to the leg times the square root of 2. So you're going to have to memorize that. The hypotenuse is the leg times the square root of 2. So let's use that to help us find the missing side lengths. If this angle is 45, this angle is also 45 degrees. Across from this 45-degree angle, it has a side length of 10, and we know that side is going to be the same as this side because they're both legs. And then our hypotenuse would be equal to the leg times the square root of 2. So in this case, it would be equal to 10 square roots of 2. In our second triangle, this time we know the hypotenuse and we want to find the legs. So we know that 18 is equal to the leg times the square root of 2. Divide both sides by the square root of 2. And we get that the leg is equal to 18 over the square root of 2. But remember, we can't have square roots in our denominator, so we need to rationalize it by multiplying top and bottom by the square root of 2, which will give us 18 square roots of 2 over, remember, square root of 2 times square root of 2 is the same thing as square root of 2 squared. Square and square root undo each other, so we would just be left with 2. And then can we simplify our fraction? We can. 18 divided by 2 would be 9. So our legs have a length of 9 square roots of 2. Now let's look at a 30, 60, 90 triangle. The side across from the 30-degree angle is going to be the shorter of the two legs because it's got the smaller angle. The side across from the 60-degree angle is our long leg. And then across from our right angle is always our hypotenuse. So the long leg will always be equal to the short leg times the square root of 3. And the hypotenuse will always be twice as long as the short leg. So those are the two little formulas that you'll need to memorize for the 30, 60, 90 triangles. So let's look at some examples. Find the missing side lengths. So across from the 30-degree angle, that's our short leg. We need to find our long leg and the hypotenuse. Now I'm going to start with the hypotenuse because that one's typically easier. The hypotenuse is equal to 2 times the short leg. So the hypotenuse is equal to 28. And the long leg is equal to the short leg times the square root of 3. So long leg would just be 14 square roots of 3. In our next example, we're not given the short leg. So we're going to have to find that first using the long leg, and then we'll also have to find the hypotenuse. So we know that long leg, which is 15, will be equal to the short leg times the square root of 3. To make it easier for solving, I'm just going to put that the short leg is x. To get x by itself, I'm going to have to divide both sides by the square root of 3. X equals 15 over the square root of 3. We can't have a square root in our denominator, so we're going to multiply top and bottom by the square root of 3. And we get 15 square roots of 3 over 3. And then we need to simplify our fraction, so x equals 5 square roots of 3, which is equal to our short leg. Our hypotenuse is equal to 2 times the short leg. 2 times 5 is 10 square roots of 3. Remember, with multiplying, the numbers outside the radical can get multiplied together, and if we had two numbers under the radical, they could get multiplied together. But we don't multiply numbers outside the radical with numbers under the radical. For your summary, summarize how to find a missing side length in a 45, 45, 90 triangle, and summarize how to find a missing side length in a 30, 60, 90 triangle. That's all for today. We'll see you in class.